Are you familiar with the concept of experimental design in business? This video explores its purpose and application in industry and commerce. Discover how it systematically investigates the impact of various factors. Experimental design is a systematic approach used in research to plan and conduct experiments with precision. Its purpose is critical in business, answering specific questions and uncovering cause and effect relationships. This process helps businesses optimize processes and products. It provides a controlled environment for testing variables. Establishing causality is a primary goal. Control is essential in experimental design, keeping all variables constant except the one under investigation. Randomization eliminates bias by randomly assigning subjects to treatment groups. Replication involves conducting the same experiment multiple times. Blocking divides experimental units into homogeneous groups. These principles ensure valid and reliable results. Determining relationships involves establishing the connection between factors affecting a process and the resulting output. Finding cause and effect relationships is crucial for optimizing business operations. Experimental design identifies if changes in factors lead to significant changes in outcomes. This helps in decision-making and process optimization. It's a valuable tool in business. Causal inference is the primary purpose, determining if changes in variables cause significant impacts. Controlled testing allows manipulation of specific variables while keeping others constant. Optimization is achieved by testing variations and measuring impacts. Product development benefits from refining and improving products. Process improvement enhances manufacturing efficiency. In healthcare, experimental design evaluates the efficacy of new treatments. Quality control ensures product standards through monitoring and adjustments. Environmental impact assessments study the effects of factors on ecosystems. Market research uses A/B testing to assess marketing strategies. It's widely applied across different industries for various purposes. Replication involves conducting the same experiment multiple times for reliability. It provides an estimate of experimental error and ensures consistent results. This process helps identify if observed effects are consistent and not due to chance. Replication is crucial for the reliability of findings. It enhances the generalizability of results. Randomization involves randomly assigning experimental units to different treatment groups. It ensures that the estimate of experimental error is statistically valid. This process prevents bias from affecting the results. Randomization enhances the credibility of findings. It's a fundamental principle in experimental design. Local control reduces experimental error by controlling certain factors. It isolates the effects of specific variables of interest. This process makes the experiment more efficient. Local control is essential for precise results. It contributes to the overall reliability of the experiment. Experimental error refers to variability in outcomes not due to studied factors. It can arise from measurement imprecision or uncontrollable conditions. Minimizing experimental error is crucial for reliable results. Businesses aim to reduce this error through various strategies. It's essential for accurate data interpretation. Control groups serve as a baseline for comparing treatment effects. They help establish causality by showing differences from the baseline. Experimental groups are exposed to changes in factors. This comparison is crucial for understanding treatment impacts. It's a key aspect of experimental design. Blind experiments keep participants unaware of their treatment group. Double-blind trials keep both participants and experimenters unaware. This minimizes bias and ensures objectivity in results. Blind trials are common in clinical research. They are vital for unbiased data collection. Paired comparisons involve comparing two related treatments to determine effectiveness. Blocking accounts for known sources of variation. Reducing experimental error involves strategies like improving measurement accuracy. These techniques enhance the robustness of experiments. They are critical for meaningful insights. Ensuring randomization is truly random is crucial to avoid selection bias. Replication may require additional resources and time. Properly defining control and experimental groups is essential. Blinding can be difficult in certain business contexts. These challenges must be addressed for valid results. Ethical considerations involve informed consent and participant privacy. Ensuring experiments adhere to ethical standards is crucial. Ethical issues must be addressed to avoid harm. Business experiments need to consider these factors. Ethical practices ensure the integrity of the research. Experiments in controlled settings may not represent real-world conditions. Resource constraints affect the feasibility of experiments. Ensuring external validity is critical for broader applicability. Long-term effects should be considered in business decisions. These factors impact the success of experimental design. Paired comparisons are efficient for comparing two treatments directly. They help control for individual variability among subjects. This method is sensitive to detecting small differences. It allows researchers to focus on specific treatment comparisons. Paired comparisons reduce the potential for experimental error. Blocking controls known sources of variation within homogeneous groups. It increases the precision of the experiment. This technique enhances the generalizability of results. Blocking is resource efficient and improves result accuracy. It's valuable in both research and business contexts. Counterbalancing varies the order of treatment presentation. It controls for sequence effects in repeated measures. This ensures the order does not influence results. Counterbalancing is crucial for unbiased findings. It enhances the reliability of experimental design. An appropriate sample size is critical for reliable results. Small samples may lead to unreliable outcomes. Large samples increase the statistical power of the experiment. Determining the right sample size is essential for validity. It impacts the overall success of the study. In conclusion, experimental design, when carefully planned and executed, delivers robust and reliable results. By addressing key issues such as validity, reliability, and applicability, researchers and businesses alike can ensure findings that truly inform decision-making. This structured approach is essential for conducting successful business experiments and driving meaningful outcomes. If you have any questions, please feel free to reach out via WhatsApp or email. Thank you.